Chapter 2, Kinematics in One Dimension. Okay, first off, what does kinematics mean? That's a really fancy sounding word. Kinematics deals with the concepts that are needed to describe motion. So basically you can think of like kinesiology, which dealing with motion, right? So kinematics is the study of motion. Dynamics is something we're going to see in a later chapter that deals with the effect that forces have on motion. So kinematics are just the motion itself, like a ball flying through the air. Dynamics are how can you put that ball into motion and fling it into the air so that it has some speed as it's moving. So together, kinematics and dynamics together form the branch of physics known as mechanics, which are more than just people who work on your car, right? Mechanics just describes all of motion. It's a great field in physics. So we're starting with kinematics, specifically kinematics in one dimension, which means that we just have to worry about going side to side or just up and down. We don't need to do both at once. Keeping it simple for now, we will add in 2 dimensions down the road where you can go sideways and up, but that ends up being a little more complicated, understandably so. Okay, so first concept in kinematics in our study of motion is that of displacement. So displacement is the difference between some initial position and some final position. Our initial position is measured relative to some origin. So oftentimes the initial position we just take to be at the origin, but there might be some reason why you don't want to do that, right? Like maybe the origin is your driveway, but you want the initial position to be the street in front of your driveway because you don't care about the pulling out the driveway part. You care about how fast you can go down your street. Hopefully you're not street racing. And then the final position is some later position, again, relative to the same origin. So you can measure your final position relative to your same driveway potentially. Or you could just make the origin right in front of your street. Anyways, so we draw these vectors to say, hey, look, I started out at this point right here. This is my start, and then this is my finish. And displacement is just looking at the difference between them. It's saying what's my final minus my initial, my x minus my x naught, or x sub 0. That the 0 denotes the initial. And displacement will just say, another way of describing it is that it's the net motion. That, okay, I started out at this point, I ended up over here, so net, I moved to the right. Right? The magnitude of the displacement is going to be the shortest distance between those 2 points. So in this one-dimensional case, it's a little bit silly, but you could imagine maybe you start here and then you put your car in reverse and back up, and then you go further forward than the car and then come back to this point, take some strange path. We don't care about that with displacement. We just care about the shortest distance from the starting point to the finishing point. So that's a good thing to keep in mind. And this will apply to 2 dimensions as well, even though we're only doing it with 1 dimension here. All right, so with this definition, let's try some examples so you can see it in action. So let's say you start out at 2 meters, and then your final position is 7 meters. What would your displacement be? I want you to come up with an answer on your own or even point in the direction of the displacement. We can do this 2 different ways. One is mathematically, we can take our final x minus our initial, and then that would be 7 minus 2. And 7 minus 2 should come out to positive 5. The other way we can do this is by saying, look, we started here, we ended up further to the right, so that means we are moving in the positive direction. Sure enough, that's what's shown here, right? That the difference between our initial and our final is 5 meters, and it shows that we have moved 5 meters to the right. And here's the subtraction shown, and the result is positive 5 meters. Okay, so this is pretty good. Let's keep seeing a couple more examples to see when the order is different, how that changes things. So here's one. What if we start at 7 meters, but we end up at 2 meters? Are we still traveling positive 5 meters to the right? I don't think so, right? If we started out at this 7 meters and continued on another 5 meters to the right, we'd end up further over here to the right. No, in this case, what we need is we need to instead start at this point, and if we end up over here, the only way to get back there is if our displacement is going to the left. So this is the negative 5 meter direction. And we can see that mathematically too. If we take 2 meters and we then subtract 7 meters from it, we get this negative 5. That negative is a key detail that tells us we have shifted in the negative direction. All right, one more example. What if we start out at negative 2 meters and we end up at positive 5 meters? What then is our net displacement? Well, we can take a look at this visually, and we start out here and we have to finish all the way over here at positive 5. So if we draw an arrow to our finish point, then our displacement is going to have to look something like this, where we've gone a net amount of 7 meters, right? You can do 5 minus a negative 2, and that now becomes positive 7. Right, so there's an introduction to displacement. One thing to note is that it is not the same as distance. And the reason it's not the same as distance is because, again, we don't care about how we got from one point to the other. We could have taken a wildly different path than what's shown here, right? I'll do that in a different color. Maybe we started here and went all sorts of wiggly room before we get back to that point. Displacement is just that short as distance. Okay, so hopefully you're feeling solid on that, not feeling too displaced. We're going to pick up speed in the next section.